Write and graph the equation of a line from a given slope and y-intercept. Student learning objectives. Given the slope and y-intercept of a line, write the equation of the line. Given the slope and y-intercept of a line, graph the line. Given the slope and y-intercept of a line, write the equation of the line. Example, the slope m is equal to 3 and y-intercept 0, 5. So of the line, write the slope-intercept form of equation of the line. The slope-intercept form of equation of a line is written in the form of y equal to mx plus b. B is the y-intercept, m is the slope. So the equation of the line is y is equal to 3x plus 5. Replace m by 3, the slope. B by the y-intercept 5. So this is the slope-intercept form of the equation of the line that has a slope 3 and passes through the y-intercept 0, 5. The standard, and then we want to write the standard form of the equation of the line. The standard form of the equation of the line is in the form ax plus by is equal to c. So from the slope-intercept form of the equation of a line, we're going to write it so that it is in the form of, rewrite it so that it is in the form of ax plus by equal to c. In other words, we want to bring the y and the x on the same side of the equal sign and the number, the constant term, to the right of the equal sign. So we start off from the slope-intercept form, y equal to 3x plus 5. Subtract y from each side. So we subtract y. We have 0 is equal to 3x minus y plus 5. Subtract 5 from each side. Minus 5 of the equal sign, so minus 5. So we have minus 5 is equal to 3x minus y. So the standard form of the equation of the line is 3x minus y is equal to minus 5. This is also okay, but we write it this way. Given the slope and y-intercept of a line, graph the line. So we have given the slope. So we're going to graph the line. This is the same slope and y-intercept from the previous example. So we have a rectangular coordinate system. The y-intercept is 5. So let's put the 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's do the same thing. 1, 2, 3, 4, 5, 6, 7, 8, 9. To the left, 1, 2, 3, 4, 5, 6, 7, 8, 9. One, two, three, 4, 5, 6, 7, 8, 9. So this is the x-axis, this is the y-axis. The y-intercept is 0, 5. So we're going to put 0, 5. 0, 5 is the ordered pair, this point. The slope is 3. What does the slope mean? The slope is change in y over change in x, which we say is rise over run. So rise means, so what we have here, we know what one point on the graph, the y-intercept. So this will be our starting point, the y-intercept. From this y-intercept, the change in y is rise. Rise, in this case, it is equal to 3. And the run is 1. The denominator is 1 for the slope. Since the number 3 is positive, rise means we're going to go a vertical distance in the positive y direction, 3 units from the y-intercept. So from 5, we go up 3 units. 1, 2, 3. We stop at 8. That is for the rise. And then we have to do the same thing for the run. The run is the horizontal distance. So we either go in the negative x direction, if it is negative, or in the positive x direction, if it is positive. In this case, it's positive 1. So from the point where we stopped, which is at y equal to 8, 0, 8, from that point, we're going to go a horizontal distance in the positive x direction, 1 unit. So we're going to move 1 unit, so this will be the point. So we found a second point on the graph of the line whose intercept, y-intercept is 0, 5, and slope is 3. So now we connect the two ordered pairs, and then we extend the line beyond the ordered pairs. So this is not exactly to scale, but it should be, if it is to scale, it should pass through the correct x-intercept as well. So this is the line. This is the graph of the line that has a slope 3, y-intercept 5. Now, for the slope, we could have used the numbers. Since the slope is positive, the numerator is, if and the denominator are both negative, this is also positive 3. So we could have risen negative direction. That means we could have gone down in the negative direction vertically on the rise. So from the y-intercept, we could have gone from 0, 5, we could have gone down 3 units to represent that minus 3. 1, 2, 3, and we would stop at 2. And then the run part is also negative. So that means we go from that point where we stopped, 0, 2, we go to the left to represent that negative 1 by 1 unit. So we go to the left by 1 unit, and that point would have been, since it's not to scale, but it would have been a point here. So this point here would be negative 1, 2, would have been the second point. Now here we have the y-intercept 0, 5, and then using the 3 over 1, the rise over run, this point here is 1, 8, or negative 1, 2. Okay. And we could have, instead of using the first point that we used here, we could have used the y-intercept and the second point and connect the two lines and the 2 points and extend the line. Either way, we can graph.